All right, so in this video, I'm going to go over a cookbook that we've prepared that allows a user to build a RAG system that connects to MCP sources or MCP servers. What that is formally in FedRAG is an MCP Knowledge Store. And if you unpeel that layer, actually, it's also a NoEncode Knowledge Store. And what NoEncode is essentially a new term, but with traditional RAG systems, right, you have a step of encoding the context and pushing up the embedded chunks into a vector store. And then when you do your inference with the RAG system, you encode the query with the same retriever or embedding model, and then you retrieve against that embedded query in your vector store. And that's traditional RAG, right? So you got your documents, you embed, and you go into a vector store, and then you query, embed, vector store, search, retrieve, and then you can generate. With what we're trying to establish here is an MCP knowledge store. So again, that we can get a RAG system that is hooked into MCP servers. What we've introduced is this so-called NoEncode RAG, where you actually, just as the name suggests, you skip all the embedding steps altogether. And in this case, your knowledge sources are, again, like MCP servers, APIs, or databases, but in this notebook, it will be an MCP server that we are hooked up to, in fact, two of them. And the way that you would query a NoEncode RAG system is essentially the same as before. You just submit the query, except this time you are not embedding it. You're using the natural language query to retrieve against the NoEncode knowledge stores, and then you would follow the downstream path as you would before: retrieve, then generate. So again, to the main difference between traditional RAG system and NoEncode RAG systems are that with NoEncode RAG systems, you don't have any embedding model because you're not encoding the queries or the context. You're using just natural language for querying. Okay, I should note that how that looks like in FedRAG, once you actually have the RAG system built, so a NoEncode RAG system, the API for querying it, for inference with it, is all the same. Okay, and just for folks who are not familiar with Model Context Protocol, though I doubt these days as MCP is very hot, MCP provides a standardized way for AI systems like RAG systems or agents to communicate with MCP servers that expose essentially tool calls or data sources to your LLM applications. And in this notebook, what we're going to do is we're going to have two MCP servers that will act as essentially what we call knowledge sources in FedRAG, and they will provide the knowledge to our knowledge store. And the first MCP knowledge server is going to be one that is provided officially by AWS Labs, and it is an MCP server around their Kendra Index. And then another one, we've built an MCP server around Llama Index's LlamaCloud enterprise product. So essentially, these two MCP servers will be the way to think about it is two separate RAG systems stood up by in a fictitious setting, set up by third-party providers, and we are hooking up into this knowledge source in order to make these knowledge sources in order to make our MCP knowledge store even more knowledgeable, right? The more knowledge we have, the hope is that we are able to answer a lot more queries within our RAG system. Okay, so why don't we dive right into it and get into our first MCP knowledge source, which is, again, an AWS Kendra Index MCP server. And so what I'll show you first is, like, you gotta create a Kendra Index. So I've gone ahead and done that, and I've created it here. What I've done is added one data source, which is essentially the Raft paper, which introduces retrieval augmented fine-tuning technique, which is a RAG fine-tuning technique. And I've indexed that here. Very simple to use, as with many AWS products. And yeah, so once you sync it, it's indexed, it's chunked automatically under the hood by their services, and we can go ahead and query it. And because they've exposed an MCP server and FedRAG now has MCP integration and support, we can connect to it quite seamlessly. Okay, so that was a prerequisite step. You got to create the index and note down the information on that on that index that you've created. So namely, you need the index ID and the region in which it was created. And so once you've got that, the next step is to build the Kendra Index MCP server Docker image. And this is detailed in their links here, or official documentations, and I've linked it here. So you could follow along there, or just look at these sort of streamlined instructions that I've created here for us. So what you got to do is you got to clone the AWS Labs MCP GitHub repo. Then you got to cd into that directory, actually the specific MCP server directory, which is the Kendra Index one, because they offer tens, maybe hundreds of AWS MCP servers. And once you cd into the Kendra Index MCP server, they've got a Docker file there available, and you can build the Docker image. So what this MCP server will do is it will run locally, but it's just essentially connecting to that remote Kendra Index. So we'll have the remote Kendra Index, which is up and running now. And once we build this Docker image, it can interact with that remote Kendra Index. The other thing is you'll need a .m file to store your secrets. But once you have these elements, then you can go ahead and build your MCP Knowledge Store. And I just want to make sure I restarted this. And if let me click that. Let's now take a look at how it is that you would build an MCP Knowledge Store source. Sorry. There it is. It's a little bit finicky with me. Okay, so important to note that for MCP servers, there are two types of transports. There's the standard IO as well as the streamable HTTP. Streamable HTTP are for servers that you're connecting to remotely, and standard IO are for servers that you connect to, that are essentially being proxied locally. And that's what we've got here. So what we need to provide are, from the MCP library, the server parameters. And as it pertains to FedRAG, we need to build this MCP Studio standard IO knowledge source. And this server parameters will be a parameter within that knowledge source. And this command here, all of this again is actually detailed in the AWS Labs repo, and all this sort of information comes along with any sort of MCP servers that you build, which is like the command to actually run the MCP server, so that your client can actually execute it, so that it can interact with the server. And so if I hit enter here, we'll have I need to hit enter here first and bring that in. And if I execute that, then we're going to have our server, our MCP Studio standard IO knowledge source built. And with that, we can actually retrieve from it. So in this index, we've put in the Raft paper. So I can ask what is Raft and see what happens. And when I take a look at this, this is a MCP native object, by the way. So if we now take a look at this and see what happens, what I'm saying here, in order to go from this MCP native call tool result class to what we need in FedRAG, our knowledge nodes, we have this function, which is call tool result to knowledge nodes list, which is essentially a converter function that converts these objects to knowledge nodes. And all MCP sources have a default function for this, but the default function might not work in all cases. In fact, it probably won't work in most cases. So it's something that you had to play around with. And here, let's just take a look at this default conversion. So from that call to result, only one knowledge node was created, and you could take a look at the text content of this knowledge node, and it's essentially a JSON payload. And it doesn't look like this is really tight in terms of this is the only information that we want to pass downstream to the generator LLM to generate a response. What that signals to us is that we should build in our own converter function. And in FedRAG, what we need to do is essentially build this this function here, which takes in a call to a result object and potentially some metadata, which is a dictionary object or none. And this metadata object is what will get passed to your knowledge node eventually. You could leave it as none if you don't want to attach any metadata. And in this Kendra Index converter function, what I'm trying to do now is actually I'm just trying to take the JSON payload that has to do with the excerpt piece and only store that as part of the text. So it's looking for the excerpt key right here, doing some cleaning up, and then it's storing it in that text content. And I'm creating a new knowledge node with that text content. And if I do this, we can now test out this converter function just on the previous call to a result that we got. And you can see actually now, instead of one node being created, there were 4 nodes being created. And the reason why that is because, if I'm not mistaken, the call to result contains a series of these or sequence of these payloads which are essentially text contents or media resource contents. And we only want to get the text content because as it stands today, FedRAG supports fine-tuning of text-only RAG systems. But hopefully in the future, we got multimodal capabilities. But if we look now at the first created node, you can see the text is not a JSON payload, but it looks like the first 500 characters at least. It's just the excerpt, it's just text. And this is much better, right? This is what we want to pass down to the LLM generator. And so what I'm going to do next is I'm going to modify that MCP source, right? So this is an MCP knowledge source that, again, is connected to the Kendra Index MCP server that we've set up. And what I'm going to do is I'm going to change the default converter function, because it doesn't work well with my case, to this new one here, right? Which again takes a signature of call to result, an optional metadata that you want to attach to the knowledge nodes, and spits out the knowledge nodes. So I'm going to use this converter function now for my MCP source, and to do that, you just do dot with converter. We support the Fluent style, and you could pass in this converter function. And what I'll do is I'll stop now and create a part 2 to this video where we'll go over the LlamaCloud MCP server.